In section 11.5, we talk about graphing using the slope and the y-intercept. And so we can graph a line if we know the coordinates of 2 points on that line. We can also graph a line if we know the slope and the y-intercept. So we want to draw a line that has a slope of 1/4 and a y-intercept of 0, 2. So what this means is we know we have 1 point. We need 2 points to make a line. Our first step is always to graph the y-intercept, which is 0, 2. So let's plot that point first. The slope tells you the direction you need to go to find the second point. And so step 2, our slope is 1/4, and that's positive 1/4. And so there are 2 directions we can go from here. We can go up 1 unit, and then to the right 4 units, both in positive direction, or you can go down 1 unit and go to the left 4 units. Either one will leave you in the same line. So from our y-intercept, let's go the first direction. We go up 1 unit, and then we go over 4 units. So that means my second point would be there. Let's show the other direction. Starting again from the y-intercept, we could go down 1 unit and then to the left 4. And then all we have to do is connect our lines, or connect our points with a line. And so you can see we fall on the exact same line no matter which direction we went. So you always want to plot the y-intercept first and then use the slope to find the second point. So let's draw a line that has a slope of -2/3 and a y-intercept of 0, 4. So again, the first step is always to do the y-intercept, which is 0, 4. So let's go ahead and plot that point. And then we talk about the slope. So the slope is -2/3. So we learned at the beginning that we can move a negative on a fraction either to the top, to the side, or to the bottom. And so when I have the negative with the 2 in the numerator, this is like saying we're going to go down 2 units, and then you're going to go to the right 3 units because it's now a positive 3 in the denominator. We could also write the fraction like 2 over -3. In this case, we're going up 2 units because the numerator is positive, but now we're moving in the negative direction in the bottom, so going to the left 3 units. So let's go ahead and show what the first direction looks like. We're going down 2 units, and then we're going to the right 3 units. Starting from the y-intercept, let's show the other direction. We go up 2 units and to the left 3 units. And so again, you can see that my points will all fall on the same line. For the last 2, we're just giving you equations to work with, and you need to graph them. In example number 3, the equation is already in slope-intercept form. And so we know that the y-intercept is this piece that hangs out in the back that's not attached to the x. So our y-intercept is 0, 5. And so we go ahead and plot that point. And then our slope is what is attached to the x. So in this case, it's the 3/4. So this means we can go up 3 units, and to the right 4 units, or we can go down 3 units, and to the left 4 units. So doing the first one, we're going to go off just a little bit. Go up 3 units, and then to the right 4 units. It looks like it would be about there. And then in the other direction, we go down 3 units, and to the left 4 units. And for the last one, it's asking us to use the slope and the y-intercept, and this is not in the correct form to do that. So we need to transfer it to y equals mx plus b. So we need to solve for y. So we're going to subtract 2x from both sides. So we have 3y equals negative 2x plus 3. And then we need to divide everything by 3. So we end up with y equals negative 2/3 x plus 1. And so our y-intercept is the piece that's not attached to the x. So it's 0, 1 in this case. We go ahead and plot that. And then our slope is what's attached to the x, which in this case is negative 2/3. And so we have 2 directions. We could go down 2 units and to the right 3 units, or we can go up 2 units and go to the left 3 units. And so going down 2 units and to the right 3 units, or we can go up 2 units and to the left 3 units.